Hey everybody, this is Ms. Williams, and this is the Chapter 5, Section 3 video, Conditional Probability and Independence. So, conditional probability is the probability that one event happens given that the other event is already known to have happened. It's denoted with this symbol right here, and you read that as the probability of A given that B has happened. So the straight line down means given that. If you want to calculate conditional probability, then you first have to find the probability of A intersection B, which we did last section, and you divide that by the probability that B has happened. The general multiplication rule, the probability that events A and B both occur can be found using the general multiplication rule. So you're trying to find the probability of A intersection B. So therefore you do the probability of A times the probability of B given that A has happened. A tree diagram. A tree diagram is useful when calculating the probability of sequential events. The way you set up a tree diagram is that you start in the center and you have branches. The tree diagram has branches. You don't necessarily, this is the tree diagram if you were flipping one coin. You could have multiple branches. You don't just have to have two. For example, if you were pulling marbles out of a bag and you had red, green, purple, orange, pink marbles in your bag, then you would have 5 branches because 5 different colors could have happened. The probabilities goes actually on the branch, and the outcome you have is at the end of your arrow or your branch. So let's see if you can set up a tree diagram. Can you set up a tree diagram for the following situation? You have a bag that contains 4 red and 5 green beads. Pull 2 beads without replacement. So you're having 2 events happen. This is why I treat sequential events tree diagram. So this is what it would look like. First, you're going to pull a bead. There are 4 red and 5 green, so you have a total of 9 beads altogether. You have a 4 out of 9 chance of getting a red, a 5 out of 9 chance of getting a green. Once you have pulled, for example, if you're just looking at the top branch, once you pull a red, if you pull a red, then you would only have 3 red out of 8 beads left. But you would still have all 5 of your green beads left. If you had pulled a green, you would subtract 1 from the green, but leave the red the way it is. Independent events. 2 events, A and B, are independent if the occurrence of one event does not change the probability that the other event will happen. So therefore, if you wanted to find out if 2 events were independent, you would have to make sure that the probability of A given B is the same as the probability of A, and you also have to do the probability of B given A is the same as the probability of B. So that's how you prove independent events. A and B are independent events, and the probability that A and B both occur is given by this equation. There should be a open parentheses in front of that A. The probability of A intersection B is the probability of A times the probability of B. Okay? And that's it. You're going to have some problems to work in class. Have a good day.